So hi guys, today's video we're talking about the chapter 6 or the network layer. So here's a little bit introduction about chapter 6. So let's start. Network application and services on one end device can communicate with application and services running on another end device. How did how is this data communicated across the network in an efficient way? The protocols of the OSI model network layer specify addressing and processes that enable transport layer data to be packaged and transported. The network layer encapsulation enables data to be passed to a destination with a network or on another network with minimum overhead. This chapter focuses on the role of the network layer. It examines how it divides network into group of hosts to manage the flow of data packaged within a network. It also covers how communication between networks is facilitated. This communication between network is called routing. So now that we are done in a little bit introduction, let's find an activity on chapter 6 and let's try to answer this. So, yeah. So the first activity will be the IP characteristic. So instruction, reach each IP characteristic, then click connection best effort, or media independent to indicate its delivery method. So this is the IP characteristic. Does not guarantee that the packet will be delivered fully without error. So I think this is best effort. Will send a packet even if the destination host is not able to receive it. I think this is a connection test. So fiber optic cabling, satellite, and wireless can also be used route on the same packet. I think that's media independent. Packet delivery is not guaranteed. I think connectionless. Oh, or maybe best effort. No contact is made with the destination host before sending a packet. Oh, this one is the connectionless. Will adjust the size of the packet sent depending on what type of network access will be used. So this is me. So now, congratulations, you have matched the IP characteristic to the delivery methods. Now we are correct. So let's find another activity on chapter 6. So this one activity. So now this is the instruction for this activity. Read each IPv4 header function and then click the IPv4 header to field to which it's belongs. So let's start. Identifies the IP address of the sending host. I think that's a service. Am I correct? Commonly referred to as a hop count differentiation service or commonly referred to as a hop count protocol. And then again, and I think time to leave. Oh, identify the priority of each packet and protocol or maybe destination IP address or this one. Always set to 010 for IP4. I think this will be the version. Identify the upper layer protocol to be used next. Protocol. Identify the IP address of the recipient host and this one. Okay, congratulations, you have matched the IPv4 header function to their fields. So let's find out another activity for the chapter 6. So this one. So here are the instructions for this activity. Internet Protocol version 6 header fields. Read each IPv6 header description and then click the IPv6 header field to which it belongs. So identify the application type to the upper layer protocol. So I think that will be the next header. Identify the size of the data portion of the packet. Identify the size of the data portion of the packet. Payload link. Okay. When this value reaches 0, the sender is notified that the packet was not delivered. I think that the half limit. Okay. Classify packets for congestion control, traffic class. Okay. To, to, to suggest that all packets receive the same type of handling by IP version. Oh, okay. That will be the flow level. Always. Okay. Congratulations, you have matched the IPv6 or version 6 header description for the fields. So let's find out another activity again and let's try to answer this activity. Okay. Okay. This one. So activity, identify elements of a router routing table entry. So here's the instruction on how to answer this activity. A partial router routing table entry is shown. Each section of the entry is identified by a circle letter above it. Select the correct routing table entry section for each output. So the first one, the elapsed time since the network was discovered, will be the letter E. The administrative distance, source, and metric to reach the remote network, I think it's the letter C. How the network was learned by the router, I think that's the letter E. Show the destination network, this will be the IP address. The next address to reach the remote network, and this is the letter D. The outgoing interface of the router to reach the destination network, I think that's the letter F. So let's find out if I'm correct in answering this activity. So let's check it out. So yes, I'm correct. You have successfully chosen the correct router routing and entry as described. So now that we are done in answering this activity, let's find another one and try to answer that activity. So this one, um, okay. For activity, description of router function and hardware parts. So this is there are the instruction. Description of the router function and the hardware parts are provided in the table. Drag each router component name to its function description. So let's start. Connect router to external web usually over a large distance. Large distance, I think that's one for because it's a large distance. A way to remotely access the CLI across network interface. I think this is the telnet because telnet is a way to remotely access the command line interface over the network. So connect computer switches and router for internal networking. So for this, internal networking must be the oh okay. Internal networking connecting our console port. So a local port with a USB or low speed serial connection to manage network devices. So I think that's the aux port because that's the only one port that we have left in the chosen. Then for this one, for to manage router using telephone. So let's check it out if I'm correct in answering this activity. So I'm correct. So what's okay? You don't have successfully matched the router components. So there are two types. Okay. Okay. Let's reset it. Okay, that's the one interface. This is the telnet. So layer, we are connect computers each other for internal networking. So okay, this is the LAN. Okay, that's the console port and the aux port. Now I think we are now correct for answering this. Let's check it out. Okay, we have successfully matched the router component name to the function and descriptions. Now let's find another one, another activity. Okay, this one. So here's the instruction on activity, the router boot process. So drag each of the steps on the left, the appropriate field in a table, on the right to show the router boot processor order. So that's step one. Um, Load the iOS operating system folder router the drum. No, I think this one before you load. Okay, I think that's wrong. Okay, this one. Okay. Then after perform pose, load the configuration file. Oh, the iOS file for this one. Okay. Now for this one, load the iOS operating system folder from the bootstrap file. Okay, for this one and the last one. So now we are correct in answering this activity. You have correctly enlisted all other row. So let's find another one activity. Okay, none of these, none of these. Okay. Mhm. Okay. Now that we are done in answering all of the activities in chapter 6, now we'll proceed to the summary of chapter 6. Here it is. The network layer or the OSI layer 3 provides service to allow and devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes: IP addressing for end devices, encapsulation, routing, and de-encapsulation. The internet is largely based on IPv4, which is still the most widely used network layer protocol. An IPv4 packet contains the IP header and the payload. However, IPv4 has a limited number of unique public IP addresses available. This led to the development of IP version 6. The IP version 6 simplified header offers several advantages over IPv4, including better routing efficiency, simplified extension header, and capability for flowing processing. Thus, IPv6 addresses are based on one 28-bit hierarchical addressing as opposed to IPv4 with 32 bits. This dramatically increased the number of available IP addresses. In addition to hierarchical addressing, the network layer is also responsible for routing. Hosts require a local routing table to ensure that packets are directed to the correct destination network. To the local table of hosts typically contains the direct connection, the local network route, and the local default route. The local default route is the route to the default gateway. The default gateway is an IP address of a router interface connected to the local network. When a host needs to forward the packet a destination address that is not on the same network as the host, the packet is sent to the default gateway for the further processing. When a router such as default gateway receives a packet, it examines the destination IP address to determine the destination network. The routing table of a router stores information about directly connected routes and remote routes to IP network. If the network has an entry in its routing table for the destination network, the router forwards the packet. If no routing entry exists, the router may forward the packet to its own default route. If one is configured, it will drop the packet. Routing table entries can be configured manually on each router to provide static routing, or the router may communicate route information dynamically between each other using a routing protocol. In order to router to be reachable, the router interface must be configured to enable a specific interface. Enter interface configuration mode using the interface type and number global configuration mode command. So now we are done in answering on all of the activities in chapter 6, and here are the summary of chapter 6. Hope you guys like my video, and thank you for watching. Hope you guys learned something about this video. So, goodbye.